Balancing chemical equations is the core of chemistry. Like math, chemistry has lots of equations. Unlike math, one mistake in balancing of these equations can lead to sometimes catastrophic results. In today's episode, we're going to be going over the foundations of chemistry, balancing of equations. So please stay tuned. You're not going to want to miss a second. As always in my videos, I'd like to start off with outlining a procedure which you can follow for ultimate clarity and for the best practices when doing a complicated topic such as the balancing of chemical equations. This step-by-step procedure will help you get through even the most toughest problems. Like math, chemistry does require a lot of patience and time, and sometimes a lot of iterations. So please don't be scared or intimidated when you see a lot of steps. If you follow the procedure and practice with time, you'll get much better. As always, let's start off with our steps or rules. The first thing to think about when balancing chemical equations is to separate your reactants and your products, and separate each element in your reactants and your products. List them on your left-hand side and also on the right-hand side. After you list them, go ahead and list the number of moles of that particular element in the reactant and also in the product. That's step one. List the number of moles in the reactants and the products right next to the actual elements. Step two, go through the list on both the right hand side, which is usually the reactant, and the left hand side, which is usually the products. See that they all have numbers. After you check to see that they all have numbers, even one, you can go about the ultimate goal. The ultimate goal in this is to get both sides to match. You want equal numbers on the products side and equal numbers on the reactant side. Sometimes that gets tricky. You may have to put a number on one side and then counterbalance it on the other side. But you'll see more of that in the example that we go through. For now, just make sure that your numbers are listed right next to your elements and put a focus on balancing the numbers out on both sides. Both sides have to have the same amount of numbers for each element. I can't emphasize enough how much you really want to be able to get your moles balanced. You don't want an accident to happen. Step three, hold that thought. I'll be back in a flash. Okay. Step three, set about the balancing of the two halves of the equation, the reactants and the products. In order for you to do that, you should proceed in this order. Makes your life a lot simpler. Number one, balance out the metals. Balancing out the metals first prioritizes the elements. It's just convention to balance out metals before the non-metals, which leads to step two. Step two is balancing out the non-metals. Balance out the non-metals except for hydrogen and oxygen. Step three, balance hydrogen first and then oxygen. So now that you have everything listed out, the steps, procedure, let's just recap. First things first, list all the elements on both sides. I would list them vertically. It makes things a lot easier. Step two, count up all the elements on both sides that you have listed. Count the elements that are on the reactants, count the elements that are on the product side, with the ultimate goal of getting all elements on both sides equal to each other. Leads to step three, which have three sub-steps. Balance the metal, balance the non-metal, except hydrogen and oxygen, then balance hydrogen, and then oxygen. But before we do that, let's just try to make our lives a lot easier. We're going to use a little tool that I've come up with called the grid. The grid is everything that I've just explained, except more streamlined. Take a look at it right now. On your screen, you see the format for the grid. Up top is the equation that needs to be balanced. On the side, the elements. Directly next to that are the quantity of the elements that are present. Because remember, our goal is to get the same quantity of elements that are present in the reactants has the same molar quantity of elements that are present on the product side. With the grid, it makes things easier for you to figure out. You simply have to list all your elements in the beginning columns. Columns A and columns B. Columns A will represent all your elements on the reactant side. Column B will represent all the elements on the product side. Column 0 will give you where you stand initially. That's the number of elements that you have present in the reactant before you get started. 1, 2, and 3 represent the different mix matching and analysis you need to go through to get to a final result. We'll call them iterations. So from this point on, guys, I'm gonna do something a little bit different. I'm just gonna show you exactly how the grid works, and you determine whether or not it's something useful for you. I'm gonna go through a series of examples, interject intermittently by just explaining certain things here and there. But besides that, I'm just gonna let the grid play itself out, show you exactly how it works. You're gonna see the elements get lined up vertically, starting with the metals, then the non-metals, except for hydrogen and oxygen, then hydrogen, and then oxygen finally. In other words, I'm gonna move across the periodic table from left to right. That's how I'm gonna move down. So all the metals will be first, then the metalloids, if there are any, will be second, then non-metals with the exception of hydrogen and oxygen, then finally hydrogen and then oxygen. I'm going to let the pieces play out for you. So please just stay tuned. I'll interject intermittently. So here we go. Case 1 says you have the compound KNO3 plus H2CO3 yielding a product of K2CO3 plus HNO3. We want to balance out this equation. We see initially that what's balanced are the carbon and the oxygen, but the hydrogen and also the nitrogen. But the hydrogen and the potassium are not balanced. So we have to go about doing that. First things first, if you notice, I'm going to put a 2 in column 1 to represent a change of 2 to the potassium on the reactant side, since that's what needs to be balanced first. You always focus on the smaller number. You want to get the smaller number to become the bigger number. So putting a 2 there, yes, it does equal out the potassium, but at the same time, it changes the nitrogen from 1 to 2 and the oxygen from 6 to 9. That's not a problem. Immediately what we're going to do is try to balance it out on the opposite side. The K's were already balanced out, but what wasn't, or what got unbalanced, was the nitrogen. So we're going to put a 2 coefficient in front of the HNO3. That gives us 2 hydrogens, which is what we had initially on the reactant side. It also gives us 2 nitrogens, which is what we needed to get to because the last example created 2 nitrogens. It also gave us 9 oxygens. So if you look at the chart now, 2, 1, 2, 2, 9 for our reactants and 2, 1, 2, 2, 9 for our products. The chart did make things a little bit more simpler. So it is kind of effective. Whatever helps you get there. Let's try another. We have B2, Br6 plus HNO3 as the reactants that yield a product of B parentheses NO3 3 plus HBr. As we go through the grid, we start off with A. A is going to list all the elements that is involved with the reaction on the reactant side. B will list all the elements involved in the product side. So for A, we have B, N, Br, H, and O. Directly adjacent to that, under the column of 0, we are going to list the initial amount of the elements present in the reactants. So for B, or boron, we have 2 molecules of boron, 1 molecule of nitrogen, 6 molecules of bromine, 1 molecule of hydrogen, and 3 molecules of oxygen. We're gonna go now to the product side, B, and see the list is identical, B, N, Br, H, and O. Under the first column, or column 0 rather, we have the amount of the elements that are present in the product side. So for boron, we have 1 molecule, for nitrogen 3, for bromine 1, for hydrogen 1, and for oxygen 9. If we look at the initial 0 columns on both sides, we see that we do not have, or we see that we only have, rather, one element that's balanced. Although that really doesn't mean anything because it may become unbalanced when we have to balance yet another element, but for the time being, it means we don't have to pay much attention to it, and that is the case of hydrogen. Hydrogen is represented by one molecule in both the reactant as well as the product. So then we have to go about seeking the iteration so we can balance out in the order that I have listed. Again, the order that I have listed follows the rules where we start by balancing metals, then non-metals with the exception of hydrogen and oxygen, followed by hydrogen by itself, and then finally oxygen. That's how it's listed vertically. So with boron, you would also notice that the list starts in descending order from the leftmost element on the periodic table. So boron is the leftmost element, and then I head right from there. As I head right, I also head down until I get to hydrogen and oxygen. Again, I have to follow the conventions of the rules outlined initially in the video. So to balance out boron, I'm going to put a 2 in this second column, or column 1 on the product side. What that does is balance out my borons on both sides. But when I did that in my product side, I also actually increased my nitrogen from 3 molecules of nitrogen to, in fact, 6. And I increased my oxygen from 9 molecules to now 18. So now we have to worry about how to balance out the oxygen again, as well as the nitrogen, which we already had to balance out. Nothing else from now. So in the third column, for nitrogen, since it's next in our list, I'm going to put a 6 on the only compound that contains a nitrogen on the reactant side. So in front of the HNO3, I'm going to put 6, leaving us with a compound of 6HNO3. By doing that, my nitrogens are now balanced out on both sides. If you notice, it's 6 and 6. Then my hydrogens, which were already balanced, are now actually imbalanced because I have 6 on one side, the reactants, and still have 1 on the other side. So what that means is that concurrently, I also have to put a 6 in front of the HBr. That I'm going to do in the third iteration. So now my hydrogens are balanced on both sides. In addition to that, my bromines are now balanced on both sides, and they weren't before. I have 6 of those on both sides. By putting the 6 in front of the HNO3 on the reactant side, now my oxygens are also balanced, coincidentally. So if I go down the list, you can see the total balance of 2, 6, 6, 6, 18. So both chemical equations are balanced. That's the last one that I'm going to personally interject in. The next one, I'm just going to have it play out for you. And the next chemical equation that needs to be balanced out is going to be CaCl2 plus Na3PO4 leading to Ca3PO42 plus NaCl. Watch as the grid goes to work. So, guys, let's stop here. We'll continue this next week. Balancing equations is going to be a long and arduous journey. I'm AKG, and I'll see you back next week with more on balancing equations or other. If this is your first time here, please make sure to like, comment, and subscribe. I look forward to reading your comments as this helps me make better content for you. Take care.